Hey guys, today we're going to introduce and look at multiple point charges. So this is where things are going to get a little crazy, all right? So if you have more than 2 point charges interacting, you can still solve for unknown values between those charges. But now we must look at the individual relationships separately, and we may have to combine them in terms of vectors. So for example, if we have charge A, B, and C, and I want to find out the total force on charge B, I would look at charge A and B and C and combine them. I need to look at the pairs individually and then combine them together. If they are in a straight line, you simply add or subtract based on if they are the same type of force of attraction or force of repulsion. If they are in 2D, we must actually break apart the vectors. So you look at the forces separately and either combine them in addition or subtraction, or combine them as vectors. All right, guys, so we're going to jump straight in. We have a particle of a charge of positive 6 times 10 to the negative 6 coulombs located on an x-axis at a coordinate of 5.1 centimeters. A second particle with a charge of negative 5 times 10 to the negative 6 is placed on the x-axis at negative 3.4 centimeters. What is the magnitude and direction of the total electrostatic force acting on a third particle of positive 2 times 10 to the negative 6 placed at the origin? So the first thing I'm going to do, because this hurts my brain trying to think of this, is to draw a number line. And if this is 0, 1, 2, 3, 4, 5, 6, this is the first particle, which is a positive 6 times 10 to the negative 6 charge. And this is 5.1 centimeters apart. Okay, and then I'm going to go 1, 2, 3, 4. And at 3.4, this is my second particle, negative 5 times 10 to the negative 6. And this is 3.4 centimeters. And it's asking me what the force is felt on this middle particle, which is 2 times 10 to the negative 6. Okay, so the first thing that we have to do is to look at the force between two particles only. So I'm just going to go in order, and I'm going to do the force on object 1 and 3 because they gave me this and this first. Okay, so I have the force is K Q1 Q2 over R squared, which is 8.99 times 10 to the 9 times 6 times 10 to the negative 6 times 2 times 10 to the negative 6 all over, this is centimeters and I want it in meters, so I'm going to bump my decimal 2 places to the left, and it's 0.051 squared. So top of the fraction bar, once I multiply through, is 0.10788. Bottom of the fraction bar, when I square it, is 0.002601. When I divide those two out, I have 41.47 newtons, and this is a repulsive force because they are the same charge, so they are pushing apart. So this green dot is going to feel this force in this direction. Okay, now I'm going to do the same thing between the other two. Force of 2 on 3 is KQ1 Q2 over R squared, which is 8.99 times 10 to the 9 times 2 times 10 to the negative 6 times 5 times 10 to the negative 6, all over 0.034 squared, because I'm taking this distance in centimeters and converting it to meters also. Top of my fraction bar is 0.0899. Bottom of my fraction bar is 0.001156. I'm going to divide those out, and I have 77.76 newtons, and this is an attractive force. So this force is also being felt in this direction. So my total force on object C, I'm going to take these two numbers and add them together since they are both going in the same direction, and that's 119.2 newtons in the negative direction. So I took two individual forces between these two dots and these two dots, and then combined them based on whether they were in the same direction or a different direction. Okay? So this is really easy when they're on the same plane. All you have to do is add them together or subtract them to separate them. But things get a little bit more difficult when we add in a second dimension. And we're going to do some of those practice problems in the next video to break it apart a little bit. So for now, we're going to focus on point charges in one dimension, all on a straight line, and how we can solve for unknown variables. See you soon.